Hey there. In this video, we are going to look at patterns in trig ratios, or more specifically, what happens to the values of sine and cosine and tangent as the angle progresses from 0 all the way around to 360 degrees. Hopefully you've watched my previous video on circular definition of trig functions or learned it elsewhere, because as we start looking here at patterns in trig ratios as we go around angles in standard position, it's going to be pretty important that you understand that x, y, r definition. Let's look at one ratio at a time here. Let's start with sine. We will move that up there and we'll move these out of the way so we can kind of ignore them for now. The sine ratio is the y-coordinate over the radius. You divide the two of them to get this. So we're going to think about what happens as we move this here. If you think about as you move this, the y-coordinate obviously changes as that point moves, but the radius doesn't change. It's fixed. In my case here, the radius is 5. I could make the circle bigger or smaller, but whatever circle I'm using, that radius would be fixed. So essentially, the sine ratio changes as the y-coordinate changes. It follows the y-coordinate. At the beginning here, at 0 degrees, the first quadrant angle we're looking at, the y-coordinate is 0. And the radius is 5. You have 0 divided by 5, so the sine ratio is 0. As I start moving here, the y-coordinate is getting bigger and bigger and bigger, and therefore the sine ratio is increasing. As I get close to our next quadrant angle here, which is 90 degrees, the y-coordinate and the radius are becoming almost the same length. And when you get to 90 degrees, they are the same length. The y-coordinate's 5, the radius is 5, you divide those two, you get 1. So the sine ratio for 90 is 1. If I keep going here, now the y-coordinate's starting to go down again. And as you get to the next quadrant angle, 180, the y-coordinate is again 0, and we have 0 divided by 5. So for 180, the sine ratio is 0. If I keep going here, now y is into the negatives. It's getting more and more negative. And as I get to the next quadrant angle here of 270, the y-coordinate is negative 5. The radius is 5. I divide those two, I get negative 1. So the sine of 270 is negative 1. And then continue around to complete my rotation here. When I get to 360 degrees, it's going to be the same as 0 degrees. And in fact, when I stop there, it's going to change it back to 0. But 360 degrees is the same as 0 degrees. The y-coordinate is 0. And so the sine ratio is 0. 0 divided by 5 in this case. All right? Let's look at cosine here. Now you notice cosine for 0 degrees starts at 1. When I'm at 0, cosine is 1 because cosine doesn't follow the y-coordinate, it follows the x-coordinate. Cosine is x over r, so for similar reasons, as I change this point, x changes, but the radius doesn't change. So at the beginning here, x is 5, and the radius is 5. I divide those, I get 1. And now as I start moving and the angle increases, the x-coordinate is getting smaller. The radius is staying the same, so cosine is decreasing in quadrant 1. It's going down, and when I get to this next quadrant angle here of 90, now I've got an x-coordinate of 0. 0 divided by 5 is 0. So cosine of 90 degrees is 0. If I keep going here, now x is into the negatives, right? And as I get to our next quadrant angle here of 180, we've got that the x-coordinate is negative 5, the radius is 5. You divide those two, you get negative 1. So over here at 180 degrees, the cosine's negative 1. And keep going here. Now x is going back up. It's getting to be 0 when I get to there, 270 degrees. X is 0. My radius is still 5. 0 divided by 5 is 0. So cosine of 270 is 0. And then all the way back here, again, it's going to snap back to 0 when I get there, but 360 degrees, the cosine is going to be 1 again because I've got 5 divided by 5 in my case here. All right? So let's just think about those two together before we look at tangent. The sine ratio follows the y-coordinate, and if you just look at this y-coordinate, the y-coordinate is 0. The highest it is here is 5, which matches the radius. So that's why the sine, the highest it's going to go is 1 at the top there. it's going to go back down to 0, right, because the y-coordinate is 0 there. The lowest it's going to be is -1 when it matches the radius on the negative side, and then back up to 0. Whereas cosine follows the x-coordinate, so it's going to be 1 when you're over at the right here. That's the biggest the x-coordinate can be, over here. And it's going to go down to 0. And then it's going to go down where x is the most negative it can be, matches the radius on the negative side. So you got -1 for cosine, 0, and then back up to 1 here. Cosine's the highest it's going to be 1 on the right, the lowest it's going to be -1 on the left, whereas sine, the highest it's going to be is 1 at the top, and the lowest it's going to be -1 on the bottom. Now to look at tangent, it's a little bit more tricky, and the reason for that, we'll move this up here, the reason for that is it's affected by two things that are changing. Sine and cosine both involve the radius, and the radius is fixed. So we essentially only had to look at what's happening with y or for what's happening with x. For tangent, since it involves both of those, and they're both changing, we have to kind of think about two changing things at the same time here. The tangent ratio, you notice at 0, that's fairly easy to figure out why the tangent ratio for 0 is 0, and that's because y over x, you look at these two values here, the y value is 0, the x value is 5, 0 divided by 5 is 0. Now, as I start moving, as I said, both of those things are changing. The y value is changing, the x value is changing. The y value is getting bigger, and the fact that the y value is getting bigger, since it's on the top of that ratio, that's going to make the tangent ratio get bigger. But the x value is getting smaller. The fact that this is getting smaller and it's on the bottom of the ratio, when you divide by a smaller and smaller number, the result is bigger. So both of those things cause this tangent ratio to get bigger. The fact that y is getting bigger, increasing, and the fact that x is decreasing, getting smaller. And so you are going to find that it gets big pretty quickly there. It gets big quicker than sine in this quadrant here. And I get to there where the y and the x coordinate are the same. These two lengths are the same, and when you divide two things that are the same, you get 1. So tangent becomes 1 at 45 degrees. That's not a quadrant angle, but it's worth noticing while we're passing by there. As we keep going here now, the y coordinate continues to get bigger, the x coordinate continues to get smaller, so the tangent ratio overall continues to get bigger. The closer I get here to our next quadrant angle, which is 90, the bigger this can get. In theory, I can get infinitely close there. In fact, it's going to click to that point in a second, but this could get bigger and bigger and bigger. Actually, it can go up as high arbitrarily as you want. What you could say is it approaches infinity. It goes up and up and up towards infinity when I approach 90 from this side. But when I get to 90 there, it says question mark, and the reason is because if you think about it, to calculate my tangent ratio there, I have 5 divided by 0, and as I'm sure you're aware, dividing by 0 is undefined, right? 5 divided by 0. So the tangent ratio for 90 degrees is undefined. We say it's undefined. There is no tangent ratio there. On the other side here now, if we continue, now we're suddenly into where the tangent ratio is negative, and it's a negative, really big absolute value number, a really negative number. And the reason is because I'm still doing y divided by x. Almost 5 divided by a tiny little negative number is a big negative number. And as I keep going here, now that's going to be less and less of a negative number. And here somewhere I'm going to hit -1 when those two lengths are the same. And I'll pass by that, and I'll keep going here. Tangent's going to become 0 again there when I get to 180 degrees, because I've got 0, y is 0 divided by -5, that gives me 0. And then as I keep going here, tangent, as you know, in quadrant 3 is positive. It goes into the positives because both of these are negative. When I divide them, I had the same thing that was happening in quadrant 1, where y is getting longer and longer and longer, x is getting shorter and shorter and shorter. When I divide those, that value keeps going up and up and up there. Right? Even though both of them are negative, the ratio is positive because two negatives divide to a positive. And for the same reason, this is going to get closer and closer. It's going to approach positive infinity here. And again, it's going to snap to that point pretty soon. And when you get to that point, you notice again it says question mark. It's undefined at that angle of 270 degrees because I have -5 divided by 0. Again, that's undefined. And then I keep going on the other side here. Now I'm suddenly into the big negative numbers, right? Because I've got a almost -5 divided by a tiny little positive number. And then those numbers are going to get less and less negative, as in closer and closer to 0. And in fact, when you get to here again, 360, it's the same as when I started. Tangent is 0 there. So tangent is a harder one to see what's going on. It's 0 when you're at these horizontals here, 0 and 180. And it's undefined when you're at these verticals, 90 and 270. And the reason for that is because it's undefined where x is 0. So those two places is where x is 0. That's where it's undefined. And then in between there, it goes all the way up. You can have a tangent ratio of any number you want in there. In fact, it could be anything from -infinity all the way up to +infinity. All right, we'll kind of summarize what we saw there. We'll do one ratio at a time again. First of all, the sine ratio. And we saw there that the sine started at 0 when the y-coordinate was 0. It followed the y-coordinate, which got bigger here. Sine became 1 up there, then back down to 0, down to -1, back up to 0. Whereas cosine started at 1, went down to 0, down to -1, back to 0, back to 1 there. They follow the same pattern in the numbers, namely they fluctuate between -1 and 1 and never go outside of those values. They just kind of do it in a different order in the pattern, right? Sine is at its maximum here, and that is in part related to the fact that sine is positive in those two quadrants, whereas cosine is 1 there, and that's related to the fact that cosine is positive in those two quadrants. Now we saw that tangent was fairly different. Tangent we saw started at 0 and continued to increase. It actually hit 1 there at 45 degrees and continued to increase above that. And we only saw it go up to 40 or 50 or something like that. But in theory, you could get it to be as big as you wanted if the y-coordinate was that much bigger than the x-coordinate. And so in theory, it can go up to infinity. But at 90 degrees here, the tangent is undefined because you're dividing by an x-coordinate of 0. And then on the other side here, suddenly now you're dividing a big positive number by a very small negative number, so you can have a very low, very negative tangent ratio. In theory, you could have something down approaching -infinity. And those values, those really negative values, increase there, go to 0 here, and then go into the positives, continue to increase past 1 there, just the same way they did in quadrant 1, approaching infinity, but then undefined at that point at 270, and then the same pattern there. So actually tangent, it goes from -infinity all the way up to +infinity, is undefined, -infinity up to +infinity is undefined. It just keeps repeating that pattern there, like that, which I've written out here, whether that means anything to you or not. The other thing that's maybe worth recognizing here is just again what those values were at each of those quadrant angles, because that in itself can help you remember or kind of make sense of the pattern in your mind. Sine started at 0, went to 1, back down to 0, down to -1, back up to 0. And that pattern would continue if you kept going past 360. Whereas cosine started at 1, down to 0, down to -1, up to 0, back up to 1, and that pattern would continue. But the values are all the same. It hits the same values, it just starts at a different point in the cycle. Whereas tangent was 0 at the places where y was 0, and that's at 0, 180, and 360. That's where it's 0, those horizontal quadrant angles, and it is undefined at those vertical ones where x is 0, and you just say it's undefined. All right. Let's look lastly at a table here so we can kind of see that pattern in a numerical way. So there's the pattern in those three different things. I just have every 15 degrees here for the values of our angle. And you see again here that the values increase here from 0 to 1 for sine, and then they decrease from 1 to 0, and then they keep decreasing from 0 to -1, and then they start increasing again from -1 back up to 0. And again, that pattern would continue if you went past 360. Cosine, again, follows those same numbers. You can see a lot of the same numbers. In fact, that looks identical to that, right? All of the same values are possible. It just starts at a different point in the pattern. Cosine starts out at 1 and decreases to 0. Then it continues to decrease to -1. And then it turns around and starts increasing again from -1 to 0. And then it keeps increasing from 0 to 1. And lastly here with the tangent, which was, again, kind of the harder one to kind of make sense of, but tangent starts at 0 and keeps increasing. Now I've only got it to 75 degrees here where it's 3.73, but if you got to angles really close to 90, that would continue to go up and up and up there. So that's increasing the whole way, but it's undefined at 90. And then right on the other side of 90, it's in the negatives. It flips over to the negatives. And from there, it increases. It's increasing from really negative numbers up to 0, and then 0 up to really big positive numbers, and then it's suddenly undefined again. And then down on the bottom here, it's increasing. Tangent's always increasing. It has this weird flip over from big positive numbers, undefined negative numbers, but it's always increasing. All right? So that is patterns in trig ratios for angles in standard position.